Welcome back to Worms Maths Academy. We previously looked at functions, one-to-one functions and relations. So what we're going to look at now is implied domains. Implied, if you think about the word implied, it means that something occurs or you assume that it's going to happen. And with implied domains, it means a domain that's defined already. There's restrictions already on a domain based on the type of function. So here, if we have the function f of x is root x, by definition, we know that when you square root something, it has to be, whatever's underneath, has to be greater than or equal to 0. Now, I know a few of you smarty pants specialist kids out there will probably go, hang on a sec. No, it doesn't, because we've got imaginary numbers. Well, in methods, we don't ever do imaginary numbers. We're always working with the real number set, or that's our base, and codomains within the real number set. Okay, so here we say that the function root x has an implied domain of 0 to infinity, because you can't have a negative underneath the square root. Generally what we do when we want to find an implied domain is we find out what we can't have, and then we know what we can use. So now you would have seen a little bit of this before, but if I've got a hyperbola, which we have in this case here, we know that the bottom can't equal 0 because we can't divide by 0. So in this case, if we bring our 3 to the other side, x can't equal 3. So x can equal any value except for 3. So the way that we would write the domain of this, we would say x is an element of R with the exception of the number 3. And that's because it's an asymptote. Okay, so there's our domain that's our implied domain for that function. Now, the Casio class pad, you can't actually find the domain on a Casio class pad, but you can on the TI Inspire. So if we go new calculator, okay, I don't know how you look it up in this. What's that? Nope. Because usually you've got that little booklet thing, which enables you to bring up all of the functions in the calculator itself. Okay, I can't seem to see it anywhere. We can type it. So if I say, we don't need shift on, domain, and then just then we had bracket, division, 3 on, what might have been 2 on. It doesn't really matter. X minus 3. Let's change it to a 2. And then we'll right arrow and we do comma x. Hit enter. And that tells us that x can't equal 3. Now if we did exactly the same thing here, if we grabbed all of this, copy, paste, and next function was square root x minus 6. Hit enter. And that tells us that x is between 6 and infinity, and it can include 6. Now, I mean, it is good that it can do that. Our class pad, as far as I know, there is no functionality to do that. I mean, you can graph a function. So if we clear this, if we said square root x minus 6, we'll see that x is from 6 onwards. So I guess that's one way of doing it. But as far as I know, out here, there is no way to check and see the domain of a function. Complex list. Yeah, I don't think there's any functionality in the calculator. However, we can also do it by hand. So we know in this case here, underneath the square root has to be greater than 0. So 6 minus x has to be greater than or equal to 0. You can square root 0, of course. So in this case here, if we bring our 6 to the other side, we get negative x is greater than or equal to negative 6. And when we divide our negative across, don't forget that our inequality sign, when you divide or multiply by a negative, it flips around. So x is less than or equal to 6. So that's our domain. So you could say x is an element of negative infinity to 6 with a square bracket. Or you could also say that, that's fine. Just to test, if I put in a value that's less than 6, say 2, we're going to get 6 minus 2 and then we can square root that. But if I put a value greater than 6, say 8, 6 minus 8 is negative 2. We can't square root negative 2, so we know that we've got the right domain. When it starts to get tricky is when we have a quadratic underneath, because 16 minus x squared has to be greater than or equal to 0. You can't solve this like a normal equation when it's an inequality. You have to use a difference of 2 squares. So 4 minus x, 4 plus x is greater than or equal to 0. Then we're going to draw a small sketch. So there's 4, there's negative 4. Because it's a negative x squared, it's upside down. And we want to know when this function is greater than or equal to 0, which you can see there, it's greater than or equal to 0 for these values from negative 4 to 4. So we say negative 4 is less than or equal to x, which is less than or equal to 4. Or you could say x is an element of square bracket negative 4 to 4. And of course we can test it. If we put a value that's bigger than 4, say 5, let x equal 5, we get 16 minus 25 square rooted, which you can't do. So this domain is correct. That's our implied domain. Now we will learn a little bit more about this later, but when we've got two functions that are added together, the domain of those two functions is the intersection of their singular domains, their singular implied domains. So if I have x plus 6, well, that has to be greater than or equal to 0. So x has to be greater than or equal to negative 6. If I have 2 minus x has to be greater than or equal to 0. Minus x has to be greater than or equal to minus 2. So x has to be less than or equal to 2. Remember, our inequality switches as a sign. So if we draw a number line, there's negative 6. There's 2. Greater than or equal to negative 6, we colour it in and go upwards. Less than or equal to 2, we go downwards. Where do they cross over? From negative 6 to 2. So our domain is negative 6 to 2 inclusive. Now, the reason that's our domain is if I put in a number outside of this domain, let's say 3. If I put 3 into this function, 3 plus 6 is 9. I can square root it, that's fine. But if I put 3 into this function, 2 minus 3 is going to give me negative 1. We can't square root negative 1, so that would be undefined. So our implied domain is from negative 6 to 2. Now this is very similar to this question. We've got a square root of a quadratic function. We want to know when that's greater than or equal to 0. X minus 4, x plus 1 is greater than or equal to 0. So if we sketch that, negative 1, 4, and it's a happy face. So in this case here, when are we greater than or equal to 0? Well, we're greater than or equal to 0 when x is greater than or equal to 4, or when x is less than or equal to negative 1. So we could test it. We could put in a value in between those. Let's say 0. If we put 0 into it, you get 0, 0, negative 4. We can't square root negative 4, so that wouldn't work. If we put 1 into it, we would get 1 minus 3 minus 4, negative, can't do it. If we put negative 1 into it, it's fine, it will work. So that's our domain. Now if you look here, this function here and this function here, they're exactly the same, except here I've got 1 on. So the significance of having 1 on is we know that here it had to be greater than or equal to 0. But in this case here, because it's 1 on, it has to be greater than 0. Because if the bottom was 0, if you square root 0, you get 0. You can't divide by 0. So x squared minus 3x minus 4 has to be greater than 0. So then from that, we can say x has to be less than or equal, not less than or equal to, I just went through that, negative 1, or x is greater than 4. You could also say x is an element of negative infinity to negative 1, or 4 to infinity with round brackets. Okay, so implied domain is a domain that is basically, it's given to you by the function. The function tells you which values you can and can't use. So it's implied using the function. Next, we've got hybrid functions, which you should have done in year 11. So let's have a look. For x is less than negative 1, so we'll start and say, okay, here's negative 1, negative 2, negative 3, negative 4, 1, 2, 3, 1, 2, 1, 2, 3, 4. Now in this case here, we know that we can't have negative 1 in the top one, but it's going to start at that point with an open circle. So if we put negative 1 into here, what's negative 1 squared? It's 1, plus 1 is 2. So negative 1 gives us 2 with an open circle. Then let's put in a value less than negative 1. So let's put in negative 2. Negative 2 squared is 4, plus 1 is 5. So negative 2 is going to go up. So it's going to look like a parabola like that. I know that it would usually come down and continue on like that. So that's how we know the shape. Okay, so we're done with that function. Now this one's inclusive, so if I put negative 1 into this, negative 3 times negative 1 is 3. Take away 1 is 2. So at negative 1 we can colour that in now because it joins up. And then it's got a gradient of negative 3, but we can also substitute in 1 to see what it's going to be. So here, negative 3 minus 1 is negative 4. So 1 is 1, 2, 3, negative 4. So it's going to look like, what did I stuff up? Oh, on the calculator I've done a completely different graph. That's okay though. Okay, so let's have a look at this graph by hand. That's going to go down to negative 4, which is down here. And we know it goes through negative 1, so it's going to look like that. Okay, when it's greater than 1, if we put 1 into it, I get 2 minus 2, which is 0. So there's 0. And it's got a gradient of 2, so as I move across 1, it's got to go up 2. Across 1, it's got to go up 2, so it's going to look like that. So in this case here, we know that this value down here is negative 4. So it's 1, negative 4. And it goes upwards forever. So if I said, what's the domain and range? Well, our domain, x, is an element of negative infinity to infinity. Y is an element of negative 4, because it starts from negative 4, and then it goes up forever. So negative 4 to infinity. Okay, when you want to put it in on both of the cases, on this case, Math 3, you can put in multiple functions here. So I could go 2x minus 2, x is greater than or equal to 1, and continue to put all of your equations in. 2, I'm just going to put something in there quickly to show you. negative 1 is less than or equal to x, which is less than 1. And then here I could do x is less than negative 1, interactive define, and there's our function defined. We go into here, we put in f of x, f of x. Okay, so there's our function. Likewise for this add graphs, we want to put in a piecewise function. Now, there. Oops. Okay, so if you hold it down, obviously on your calculator it's different, but if I hold down 6, then it'll give me a 6 piecewise function. You just put it in like we did before on the other calculator, and it'll spit out the function. Instructions are there as well. Okay, odd and even functions. So, an odd function has the property that when I sub negative x into it, it's the same as that. So here, when I sub negative x into it, it's the same as reflecting it in the x-axis. So reflecting it in the y-axis is the same as reflecting it in the x-axis. If I sub in negative x, it ends up being the same function that I started with, then that's called an even function. Okay, so let's have a think about functions that we know. X squared plus 7, if I say what's f of negative x, I would get negative x squared plus 7, which is x squared plus 7. And that is exactly the same as f of x. So in this case here, we would say that this is an even function. And if we reflect it in the y-axis, x squared plus 7, it's exactly the same graph. This function here, f of x, if I sub a negative x into it, I get negative 2 negative x cubed plus 7. When I cube negative x, I'm going to get negative x cubed, so that's going to be positive 2x cubed plus 7. So that's not positive f of x, and it's not negative f of x. It's neither. Because if I took a negative out, I get negative 2x cubed minus 7, and that's not the same as that. And if I just leave it as it is, they're not equal either, so it's neither. Okay, this one here, when I sub in negative x, I end up with 1 on negative x, which is negative 1 on x, which is negative f of x. So that means that this function is an odd function, and that's the same as reflecting it in the x-axis. So we say that that's odd. This one here, f of negative x is negative x to the power of 5 plus negative x to the power of 4 minus 3 times negative x. So that's negative x to the 5. That's plus x to the 4, because when I put negative 1 to the power of 4, it's just positive. And then the last one's going to be plus 3x. Okay, so they're not the same. If they were the same, then it would have been even. If I take out a negative, x to the 5 minus x to the 4 minus 3x, are they the same? No. The difference is here, I've got negative x to the 4 and here. So this one here is neither. Now, so that's working it out and showing it mathematically. But what I'm going to tell you is there's a quicker way to work it out with polynomial or with functions that don't involve sine, cos, and tan. If you look here, that's x to the 2. This is basically x to the 0. And 0 we assume is even. So this function here is even. This one here is x to the 3 and x to the 0. So I've got an odd and I've got an even, so it's neither. This one here is x to the 1, so that's going to be odd, as we said. This one here is odd, even, odd. Now when I've got a mixture, that's going to be neither. Now, with this here, I've shown on how to do on the Casio class pad. You define the function, and then you use the judge function. So x squared plus 7. So if we go define x squared plus 7, define, then if we click on this drop down and then go into J for judge, and then we say, does f of negative x equal f of x? True. So that means that that's even. If we said, does it equal negative f of x? It says false. So we know that it's not odd. Because if that was true, then it'd be odd. If that was true, then it's even. So let's put in an odd function now. So I'll change it to 7x and hit enter. You can see it's neither odd or even. But if I made that to the power of 4, it's now even. If we changed it and I said x cubed plus 8x to the power of 5, the bottom one should be true because that's an odd function. Now it's similar with the other calculator. We just go define. No, it's in here. Actions define. F of x equals, this is driving me insane, I can't remember where anything is, equals x squared plus 5. Now on this cas, we just simply go f of negative x equals negative f, got to go back and delete that other one, negative f of x, hit enter, doesn't say yes or no, basically says nothing. Okay, then we grab the same thing again, but this time paste it. But this time we want to see if it's, see it says true, then that means that this function is even, because f of negative x is equal to f of x, because it says true. So that's one way to test it in the TI Inspire. Okay, so state the implied domain for this function. So 1 on x squared minus 3x minus 1. So we know x squared minus 3x minus 1 has to be greater than 0. Can't be equal to 0 because you can't divide by 0. Now this doesn't factorize, so what do we do here? Well, complete the square. X squared minus 3x. If we halve 3, we get 3 on 2. If we square it, we get 9 on 4. Because we've added 9 on 4, we've got to subtract 9 on 4, and then we've got our minus 1 on the outside. X squared, x minus 3 on 2 squared minus 13 on 4 is greater than 0. Then, of course, from here we can say x minus 3 on 2 plus, now we can make this root 13 on 2, all squared. So plus root 13 on 2, and x minus 3 on 2 minus root 13 on 2. Is greater than 0. So our x-intercepts would be 3 on 2 plus or minus root 13 on 2. Now if we were to sketch that, we're going to get 3 on 2 plus root 13 on 2, and 3 on 2 minus root 13 on 2. It's going to look like that. When is this greater than 0? When x is less than 3 minus root 13 on 2, or x is greater than 3 plus root 13 on 2. Now we could check it. 1 on x squared minus 3x plus 1. Let's go to this calculator. I don't know how to open the books. Oh, that's how you get all that other stuff up. Didn't we have one with domain in it? Okay, so copy, paste, get rid of that. Okay, so we want a fraction, 1 on x squared minus 3x minus 1. Hit enter. Okay. Oh, it's not a square root. I just realized. Or is it a square root? No, it's not a square root. So it just can't equal those values. That was my stuff up. I was thinking it was a square root, but it's not. It's just a normal function. So at the bottom can't equal 0. So in this case here, we don't need to graph it because it's not an inequality. We just need to know when it equals 0. So we get x is an element of all reals with the exception of 3 plus or minus 3 plus or minus root 13 on 2. And that makes sense because there's two values that it can't be. Those two values that when you can't factorize, doesn't perfectly factorize, you complete the square, but they're the values that you can't have. And if you sketch that, we don't have to sketch this in methods, but if you sketch that, you'll see that there's an asymptote at both of those values, because that's what makes the bottom equal 0. Okay, this function here, is it odd or even? Well, just looking at it, we know we've got a 2 and a 4 as powers, so we know it's going to be even. But it says show working for your answer, so f of negative x, that's equal to 1 on negative x squared plus 2 negative x to the 4. What happens when I square a negative? I get 1 on x squared, becomes positive, plus 2 negative x to the power of 4 is just x to the power of 4, and that's equal to f of x. Therefore, as f of negative x equals f of x, this function is even. Okay? And of course you could define that in your CAS, sub in negative x. You can actually test and see if f of negative x equals f of x, or f of negative x equals negative f of x. You do need to know how to do it by hand as well though, because they could do it on a calc-free exam. But in this case here, the function is even. Okay, I'll be back soon with sums and products of functions, and it's very important that you know your domains and ranges for that topic and everything later on. Okay, see you soon.